Hi, welcome to this Open Security Summit in November 2021. And we have Christian, who's going to walk us through what I think is a super important topic around threat modeling, especially how to do it at scale with Agile and actually using a lot of open source tools, which basically is a great place to start. So Christian, over to you.
Thank you very much. So perfect for having me. Thank you very much. Really enjoying that. So I'm, as Dennis said, Christian Schneider. I'm a security architect, penetration tester, and a trainer, freelancer in that area, and do agile threat modeling and security architecture and stuff around DevSecOps. And today I'd like to speak about threat modeling at an agile scale and doing it with open source tools. So just a short introduction, classic threat modeling, that's basically the architecture analysis from a security perspective. So it's about something like whiteboard hacking, if you want to name it that way, and identifying potential risks. And well, the question would be, are you doing it? Are you doing it for every release? What about for every release in Agile? That means for every sprint, possibly. So that's most of the times not done on every sprint, or at least the initial created threat model is not always enhanced and adjusted accordingly when the architecture is adjusted in a sprint. So that's not close to some DevSecOps or DevOps style approach. And that means the models can possibly erode to some degree over time and not longer reflecting the state of the architecture actually. So I wanted to try to bridge this more into the DevSecOps kind of thing and to be something more agile in that regard. And that means to try to automate some kind of threat modeling stuff as best as possible. And in the DevSecOps approach, everything appears to be, well, some kind of code or declaration of something, some declarative stuff. So some kind of automation magic. So the idea was, why not let the threat model be something like code? So to have the same benefits. What are the benefits of something like code in a DevSecOps or in an automation way? It's editable in any IDE, definitely. It can be checked into the source tree. So it lives where the project lives. So you can diff and revert it and stuff like that. You can even merge it. So it's easy to collaborate with colleagues on that model. If it's checked in with a project, it's something like code. So that's definitely where we can easily collaborate on. Can be tested, can be verified to some degree, and it's creating reproducible results out of that. And it states clearly states the most recent update in the revision history. So you can see comparing how the project's code base evolved in terms of merge requests or the code base itself. And so you see lots of architecture changes possibly. And well, the model did not reflect that because it's just left stale in the repo. Then that's a clear sign that the model is no longer updated. So that's easy to spot also as well. And developers love code, at least I do. And they know the application best. Well, that's something very interesting. Might be some more benefits, definitely, but that's, well, just not an exhaustive list, just to have a few. But there are also some drawbacks of having models being something like code. One is the obvious one, it's code. So it means someone has to write it. Some people might find code hard to read or hard to create. Well, it's definitely also a point. So because in terms of threat modeling analysis, we sometimes have to speak with business people, not always with development teams. And it starts with the details. That's a very critical drawback. It starts with the details, not the abstractions. So it's not easy to spot this very important big picture of an architecture in terms of security, but just looking at the details. It's a very valid one. Might again also be some more drawbacks of having threat models being something like code, but that's just a few of these few examples. And well, how can then threat modeling become something that's more fluent in agile projects and more compatible to those DevOps things? Well, then the idea was to use something very simple that combines the most of the benefits of something like code and has on the other side only as few as necessary of those drawbacks. That means not actually being something like code, but something similar to code, something more declarative. And the easiest to read markup language in my personal eyes, at least for a human, is YAML. So that's even easier to read than XML, obviously. And it's still very clearly defined, so it's very easy to parse, and all the IDEs can understand that. And we're having some more YAML kind of stuff in all those DevOps configuration things and how to define your DevOps pipelines, for example, and stuff like that. So developers are used to that. So the idea was to use that kind of idea to have a thread model as a YAML file, in which you can describe, like in the actual thread model analysis, the data assets, not in terms of attributes and stuff like that. That's very, very too detailed, no, just in terms of the categories of the data you're dealing with. Because threat modeling also speaks about risks, and that means risks of data being breached, and some data are more valuable than some other data. So, for example, health data being very critical, of course, and very sensitive in these areas compared to, let's say, reporting data or stuff like that. So we can describe the rough data assets we are having in our architecture in that model, and the components. These are the boxes one would usually draw in such a classic threat modeling workshop on the whiteboard, and the connections between them. So what component is speaking to what other component? The communication links. And at the end, you model the trust boundaries. So those kinds of boxes where the actual isolation happens, so that you isolate some components against the rest of the world or some other components. This is like in classic on-prem networking stuff. This is the network segmentation stuff like VLANs or DMZs. On the cloud, this is the security group thing. Or in the managed container clusters, it's stuff like the network isolation thing. So very isolate the reachability and visibility of components, and more being more secure in those areas. Trust boundaries. Then the idea was to use an open source tool to analyze that kind of YAML file as a graph of connected components with data flowing between them. And I did some search on that, and was not 100% satisfied with the candidates that I found, but then I thought, okay, so there must be something that we should create that generates then out of this model file the nice model graphs. We still, as a human, need the visual representation, of course, so that we can spot whether we've possibly misplaced a component in a wrong area, in a wrong trust boundary, or whether we've modeled or missed to model a communication link in the wrong way. And so we just, as a human, definitely need to get this big picture, but that can be generated from that model. Also, threat modeling being about threats and potential risks and all these things. So these should be generated from the model by analyzing it as well, obviously. Including the hardening recommendations or the mitigation recommendations for the development teams or the architects on how to mitigate those identified potential risks. And that's for big corporations and organizations important. So all those required documentation stuff would be great. So to have some documentation and reports generated as well. That's actually the idea of agile threat modeling. So to have something that tries to bridge the gap between classic threat modeling, which is very human and workshop intensive, and that's still very useful. So you always have some kind of threats that no tool can ever identify, but it's not feasible to have this classic threat modeling workshop happening on every sprint. So that means to have some kind of baseline agile threat modeling that can be used to try to bridge that gap. That's the idea. Well, and that's exactly what Threagile is about. That's an, if you want to name it like that, an agile threat modeling toolkit, something around that. It's a good definition. Threagile, that's open source on GitHub and Docker Hub. I created that last year, and it's released under the MIT license, so very permissive open source license. And that's doing exactly that. So you model the classic threat modeling things in a YAML file, including the data assets, the technical components, as well as the connections and trust boundaries. And the tool does analyze that as a graph of connected components and has some risk rules built in that can also be extended to derive those aforementioned things like the model graphs, potential risks, mitigation recommendations, and stuff out of that. So with Threagile, you are modeling in a technology-aware style. So it's more on the detailed side of modeling in terms of defining what, for example, for a communication link, what protocol is being used, or for a component, what type of component is that, technically speaking, web server, message queue, database, stuff like that. And there are over 40-ish risk rules continually growing. That's checking those model elements, the model graph for those risks or these potential threats. You have, of course, a custom risk rule plugin interface that you can extend the risk rule set with your own custom rules if you want. Some more values are being calculated, more on that later in a few slides. There are also model macros existing. That's something like to try to have some automated model modification via a wizard style question back and forth to read in an existing model file and then modify it in a certain style, like adding build pipeline or like adding identity provider stuff and something like that by asking the modeling user some kind of questions and then emitting a modified YAML file as well. So, and the risk, that's very important. The risk mitigation state is also kept in that very same model. So you need to check off certain risks that you've implemented the mentioned or recommended mitigation steps, or that you're flagging it as an accepted risks, that you say you're just carrying that, not a problem, and or that you're just in the process of checking what you're going to do. So you can have those state also be tracked in that model file to reflect a updated version in the report as well, before and after mitigation state applied. It's released, of course.
And Christian, just a quick question, right? And all this data is stored in Git and version control using Git, right?
It's, yeah, as you like. So it's a text file, YAML file that you can use any kind of version control to version on that. That's definitely useful so that it evolves with the project. And when you're rolling back to another previous state, like reverting something, then the model is reverted along. So it really pays off to keep that checked in the source tree as well. Yeah, good one.
Because your raw data is stored in JSON, right?
It's YAML. So it's actually YAML.
Yeah, so YAML, yes, YAML, of course.
Close to that.
I think that's a massive advantage, right? You know, also, I'm not sure if you looked at it. Have you looked how you can reasonably easy get the history of files, you know, when you're consuming, so you can access the Git database directly, right? So you can actually think that Git also gives you the historical, because one of the things I always find that I think is also important is not necessarily, let's say, the first threat model, is the diff between the first and the second and the third and the fourth and the fifth, right? So, you know, I think, again, you know, starting to think of that diff as a first-class citizen, right, which you get by saying, can I get the difference between, you know, this commit and that commit, right, or even do versions. Right now, we now do a lot of good version control using Git with different branches, and we auto tag things, so we get an ID for each one. And it will be quite amazing to see. And by the way, here is the threat model, the diff, or if the new one, but here's a diff, because ultimately, you know, changing threat model changes the risk profile of the application, right?
Absolutely correct. And you can also recreate the previous output of those created artifacts by just running Threagile on the previous version. You even have 2 visual diagrams and 2 reports and 2 risk charts and stuff like that. So that's definitely a very good point and a useful thing. And that's coming from the fact that you're maintaining the state in the same file. So actually that's pretty useful. Yeah, definitely.
Cool.
Very cool question. Good. Yeah, as said, it's released as open source, MIT license, very permissive license, and also, of course, runs totally offline, definitely. So here it is. So it's a command line interface, nothing more. It's the classic CLI. And you can either start it in a Docker container just to work on that model file and do its work very quick. Or you can just run it in a server mode, just have a REST API and a minimal web thing to not run it on your machine, but run it on a server if you want to do that. So it's either capable of running locally or on a server where you deploy it in server mode.
Just one more thing. Do you have the Helm chart? I'm not sure if you've done a lot of work with Kubernetes, but these days I think it's important that not only you have the Docker file, but you also maybe have Docker Compose and also the Kubernetes Helm chart.
Yeah.
Because, I think a lot of environments we're starting to deploy, for example, like I think it would be really cool to deploy this to one of our clusters in development, right? Especially as you start to get, real-time feeds, because, for example, like one of the things you want to threat model is the, let's say, the Kubernetes environment itself, right? Or the relationships, or let's say an API that you can get the data feed from it. So I love the fact that I could actually run this as one of the pods, in a different namespace, but one of the pods that goes directly into a cluster that starts to provide that information during development, right? Which I think would be quite cool.
Yeah, definitely. So it should be easy to create a kind of
a Helm chart for that.
From that, but also that I would see it also related to Helm charts in a completely other way as well. So when you have existing Helm charts for your architecture, and they are also checked in, let's say, in a GitHub style. So in that GitHub style sense, it also makes sense to have the threat model at the same version checked in. And it could be possible to create a model macro for Threagile that reads Helm charts and asks the modeling user which elements from those Helm charts should be put as an initial seed into the YAML file. So you can have something like import some elements from Helm charts, for example, that should be possible to create as a model macro as well. So also.
Not really good.
Nice. Cool. Yeah. Cool questions, cool discussions. Nice. So what are the first steps with Threagile? So it's that either you create a minimal stub model and evolve on that. So you can use the stub model provided to have a starting point, or you can use the example model just to have something to play with and see how it works. At the end, your YAML file should contain your data assets, your technical assets, the communication links, and the trust boundaries. And then you execute Threagile on that. And here's a simple example. That's just coming from the model example provided in Threagile. That's a data asset modeled here in YAML. So it has an identifier, customer contracts here, an ID to be referenced inside the model, has a description, that's for the documentation generation. And most importantly, at the end, it has those 3 protection goals of confidentiality, integrity, and availability being rated on a 5-slot scale. So whether it's confidential, strictly confidential, for example, or just restricted or stuff like that. Also for the integrity and availability of that data asset. And you're doing it for every data asset as well. Here from the example model, how to model a technical asset, a component. Here it's just on Apache web server, and you're providing a little bit of question answer things here, like whether it's used as a client, whether it's used as a thing that's sitting on the internet or not. And the technology, that's a very important thing here. You can choose from a broad set of technologies: web server, message queue, database, NoSQL database, stuff like that. So it's a lengthy list of technical elements, and that's exactly important. So to have as less false positive in the threat model analysis as possible. So those risk rules that are basically watching out for those certain technologies and certain combinations of data flow things, and then they create potential risks out of that. So it might make sense to have a detailed, if you name it detailed on that level, kind of modeling where you specifically choose a technology and specifically choose protocols for communication links, so that the risk rules that are assessing the model can very precisely spot the issues. For example, you model how an if and how it's encrypted, and also here the confidentiality, integrity, availability things, whether it's used on a multi-tenant or as a multi-tenant component, and something like that. Then you're referencing, very important, the data assets that are processed and or stored on that component. So if it were a database-like thing, so it would be more on the stored side, obviously. So that's actually referencing from the set of the data assets modeled in that very same YAML file by their identifiers. And then you're modeling the communication links. That's just like having a directed graph where you're modeling a connection, so that here, for example, that Apache web server thing is now having in its communication links section an outgoing communication link, can be multiple, of course, targeting an ERP system, also by its ID from the same model, and you're specifically choosing a protocol. So Threagile risk rules see, okay, it's HTTPS, that means it's encrypted inherently. If it's an authenticated interface, the connection, then you're modeling what kind of authentication authorization style. Is it by a certificate, by just session ID, by credentials, by token, or whatever? And a few more questions being answered. And of course, you're referencing the data assets that are sent and received via that connection. So it means you're modeling on the technical view of how the connection is established, so that for the Threagile rules, it's clear to see what here the target component, what component is offering an interface and having an attack surface that way. And to also see the logical data flow, it's important to differentiate between the send and receive data assets, so that you actually see where the data from which to what component is flowing. And you also see who is opening the connection and to what other component that then has a new attack surface of offering that kind of connection interface. Yeah, and finally, you're modeling the trust boundaries in that YAML file. So that's the classic DMZ thing for the classic on-prem networking things, or the cloud security groups, or some Kubernetes isolation, network isolation policy, stuff like that, whatever fits your architecture best. So that's just by isolating the components against the rest of the model that way in a trust style. And you're referencing for those trust boundaries the technical assets that are inside, and you can even nest them, staking those things like trust boundaries into each other. Okay, and then you execute Threagile. That's just processing the YAML model file, which then is being read by Threagile, and the risk rules are executing, including the custom edit ones, if you developed some, and it creates some nice output. First, a visual representation, the model graph. Very obvious and very important. So for us as humans to spot whether we've modeled everything as we expect it to be. Here, that's from the example model provided in Threagile, a very small one, just to fit on the screen. The shapes, the colors, and that's completely auto layout here. And the colors, the shapes, and the borders, they resemble some kind of risk state as well, where the very sensitive data is flowing. Obviously, that's more on the right side then. And some PDF and Excel reports are also generated to have some kind of multiple angle view on the risk state of these modeled things. So it's a rather lengthy report because it has redundant views from different angles on the same data set, depending on from which perspective you're interested to consume that report. Of course, management summary and charts, but you do also have some impact analysis of the initial risks and the remaining risks. So you have an initial risk set and a remaining risk set. The remaining risks are those where after the mitigation state, if this has been modeled as well, second, third, fourth iteration has been applied. So how it went from the initial state to the current state. So that's the risk impact analysis here. You see the risk mitigation also. That means a risk is either on the left side in the bar chart in the state unchecked. That's the default. Unfortunately, here in this example file, there are still many unchecked risks. Project, this should be a clear sign of, well, that's something we should work on, being an example file here. And some are accepted, some are in progress, and some, the green ones, are also mitigated already. So you can see how the bar charts should by iteration, be more on the green side if everything works well. And for those remaining risks, either not yet checked or just simply accepted, you see the impact analysis for the remaining ones as well. If you're into classic threat modeling already, so then Stride might be a very good starting point. That's the classic Stride approach here of having those threats and risks categorized by spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege categories. And that's just the same thing here. So you're seeing the identified risks being categorized into those Stride categories. And also by function, in terms of which function from the software development lifecycle should possibly handle that kind of risk. In terms of either working on that, mitigating that, applying the recommended steps, or just by saying, okay, it's okay to carry that, we're accepting that. So somehow on the business side here, an example, some critical custom individual risk, that's the red one here. That's also possible to add your custom risks, obviously. So if you're still doing those very valuable threat modeling workshops, then you can come to the point that you identify things that no tool can ever identify, and why not adding them as well to the report? And you can do that in the model file. So a very critical one as an example. Some risks are on the architecture side, some are to be checked and worked on the development side, and some are just for the operations. So in terms of encryption of protocols and stuff like that, for example. Then some very interesting values calculated, the RAA, relative attack attractiveness. That's a pluggable algorithm. So you can either use the built-in one or plug your own into that. And at the end, it's trying to assess, that's very useful for bigger models, to assess every technical component and identify those components that are very attractive for hackers to attack, actually. So that means they are storing or processing very much of the very sensitive rated data, for example. And it's also taking into account the surrounding components. So if, for example, you have a value with a very high, that's a relative scale from 0 to 100%, 100 being the most interesting ones usually. So if you're having some component which has a very high scale on that, high value on that scale, and surrounding components close to that, like monitoring things and stuff like that, not at all that interested of attackers to take over, because there are no sensitive data being stored to then steal. But they are having a direct connection to the very valuable one, then they might also increase in that value. So this also takes some lateral movement stuff and some side doors and to get into the actual target things into account, like a pen tester or a real attacker would do. And the outcome is interesting for bigger models where you have to focus on the most pressing things first. And that means you see then that according to that calculation, these and those are those components that possibly should be receiving some hardening security-wise first. And a data breach probability is also on a very simple scale of either improbable, possible, or probable are being calculated. Here you see a model, a data mapping model on the left side. That's just not to be followed line by line. That's just to see the rough relative coherence between those left data assets and the right boxes, which are the technical components, and whether the data is stored or just processed there. And then you see some interesting relations sometimes. And the colors here are all red because in this example file, there are not too many mitigations already applied. And that's interesting from the data protection kind of view. So you have a view data asset by data asset where a data breach probability is calculated. And it actually takes the blast impact of those identified risks into account. So it checks on which components this particular data asset is either stored or processed. And all of these components, communication links, could be potential targets for attackers to get to this data asset because it's stored or processed on all of those things. And then it takes into account the identified risks, the unmitigated ones, and sees, okay, these are the remaining risks. And for each risk, data breach probability is also admitted by the risk rules. So, for example, an injection vulnerability might have a very high data breach probability, whereas a denial of service risk, also important for online shops to be online and available, but you're not directly risking to lose data and have a data breach by just, quote unquote, here having a denial of service attack happening. So this kind of algorithm tries to get to those risks that are not yet mitigated in the model, that are most importantly to be fixed or to be mitigated first to reduce the overall data breach probability of that particular data asset. And you have a data asset by data asset. So that's the redundancy in the report. You have three different angles. You have the angle of identified risks by vulnerability report type, then of identified risks by technology and component, by the boxes, and here by the data assets. So let's go to the mitigation things and recommendations. So for each identified type, of risk. Here you see two examples. There are some detailed mitigation steps described, including links to the OWASP, ASVS, CSVS, and cheat sheet chapters, if applicable. So, for example, you see the impact description, what this risk means if it unfolds the attack, how it's detected by Threagile, how the risk rules are detecting that, how it's being rated. Sometimes it's being rated as high, sometimes not, and that's also due to some reasoning described in the report. What are potential false positives? That's important to check. So it gives you a hint of what you have to check, whether it's a false positive, and that should be checked. And if that's true, then it's a false positive, possibly. How to mitigate that? That's the fixing things. And a check questions, set of check questions that can be asked whether it has been mitigated correctly. And then also very much linked in the report, you can click on many items, so it's easy to navigate in this big PDF. And here you see the identified instances of those risks. That means, including their state, many of them here are unchecked. That means you have a analysis by the risk rules where in that actual model file and what communication link these things have been identified. Also here, if you're working with the Threagile many times, then you know what's in the PDF in terms of description stuff. So then it's easier to use that Excel report being generated to navigate and scroll through and sort and slice the identified results and the risks. You have more or less the same data like risk category, technical asset, communication link, where it was identified, the type of the risk and the impact, likelihood and severity and stuff like that. And that's important for me, JSON, as simple as it is, we want to process this very same data in an automated way, and even in CI/CD pipelines, why not? So it's also created as some JSON report stuff. These are the built-in risk rules, and it's growing and growing. So different kinds of technology risks that can be identified. And here in a very simple example, it's written in Go, very simple to extend in that easy to read and understand language. Here you have the risk rule of an LDAP injection. That's a medium-sized risk rule. Some are bigger, some are way smaller. And on the left side, you see those text snippets and the categorization stuff to work and emit that in the report. And on the right side, you see the detection logic here for this built-in risk rule. So it's a little bit of model checking and looping and analyzing incoming data flows by protocol. And if a certain condition met, then it's appending a new risk into that report. But you can also add your manually identified risks. So that means some workshops, if you're executing them, and that still makes sense. So you cannot do it on every sprint, of course, but if you have the resources to execute a human-driven, expert-driven threat modeling workshop, go for that. Definitely very important, because every time there are risks that can no tool ever identify, more on the business side, those risks. And why not track them in the same way? So that means if you're doing this and you identify some custom risks, you can also add them to the YAML file, including those pointers to, if applicable, to what kind of component or what kind of data flow it should be linked in the report, and to what severity, for example. Yeah, editing is very simple, as all IDEs understand YAML, obviously. So you do have some structure view in all those IDEs, but you can easily click and navigate in the model. And Threagile has its own YAML schema. That means you can import that YAML schema and into the IDE, and that's just one time thing that needs to be done. And once your IDE has this YAML schema imported, then you can flag that this YAML file you're working on, a Threagile model file, should be using that imported schema, and then you get some auto-linting and some auto-completion stuff. So here I did a typo web server, and it's auto-linted in the model file then in my IDE, because it understands that's not a valid technology type, and I can start typing, and then this typical auto-completion box pops up and it shortens down while I'm typing. So that's a nice, convenient way of creating things in your favorite IDE, and you can even have some live template snippets to then just tab through and use control space stuff in some kind of Zen coding experience. And as said, the risk tracking is also inside the YAML file. So once you created your initial versions of reports, and you see, okay, now it's the model that I think it should be. And then you're having a set of risks, of course, that need to be analyzed. And all of these risks, every risk has a custom ID. And these are those speaking identifiers with the add character in it. So it's grouped by what kind of category, in what kind of component, at what kind of data flow between what other component and stuff like that. And you can either in a model macro style auto-seed the YAML file with all those new identified risks not yet tracked, so that you get a initial set of options where you can then enter your state for this risk. Default is unchecked, of course, or you can add it manually if you want. You can set a state of either being unchecked, that's the default for that risk, or in discussion, accepted, in progress, mitigated, or false positive. And that can also be flagged as this, of course. And then you can add a justification string, some reference, some date and stuff like that to keep it on the tracking side valid. And you can also group risks to assign the same state by using the wildcard thing here between those adds. But I would not recommend that because it might accidentally group more risks under that state. If you missed a few that you were not aware of and it just matches the same group, then you're funneling them into some state that might possibly not the desired one. So I usually recommend to be very specific and do it on a individual risks thing here, but you can, if you want, you can group it as well. What about bigger models? Of course. And that's still a small one. I've seen way bigger ones. But then they would not definitely no longer fit on the screen here on the slide. There's also an example model file here, but it's auto layout generated quite nicely. So there's no visual tweaks done. So it works even with way bigger that I've seen that needed to be plotted somewhere. So Threagile, being a command line interface, also can be started as a REST server. So you can just start it as a simple web server, and it has a Swagger REST API, Swagger documented REST API, that you can use it to throw in a model file and get the result out of that. And model macros are existing as well. So model macros is a way to automate certain changes. Like in a corporation, you, for example, have always the same style of build pipelines in your threat models, and you do not want the projects or teams to model them themselves in an individual thing, every team doing it differently, possibly. And then you can create a model that's asking a model macro that's like a wizard that's analyzing an existing YAML model file and then asking the user some questions. What kind of build interface or build pipeline is it that you're using? And then it's modifying, enhancing the YAML model file by adding new data assets like your code, your artifacts, the deployment units, new components like your Git repo, like your hub, Docker hub things, or like your artifact registry things, and also the connections between a development machine and the build pipeline components and the production system. Because as we've seen in 2021 by all those supply chain attacks, it's also very important to keep the code backdooring and dependency backdooring risk also, keep an eye on that, so that it's very important to have that context of a build pipeline also included in threat modeling, because that's definitely a very nice foothold for attacker to get code execution on the target systems. So modeling that kind of risk definitely makes sense as well. And if you're modeling some things in the very, very similar approach, it might make sense to automate that kind of model extension or model enhancement as a model macro. An existing one is in Threagile to add, after asking the user a few questions, to add a build pipeline to the model. It could be also something like adding a vault to the model or typical identity provider stuff. So all those cross-cutting concerns that are in big corporations most of the times done and added in the model in the same way. Then you can create your own things there, your own model macros, of course. So here you see an example that's just on the command line, the model macro to add a build pipeline is asking a few questions to the user, and you can point on what components you like to deploy and stuff like that. And then it's doing a dry run and it says, okay, change set looks valid. I would now add these things, those assets, technical assets, data assets, communication links, and those trust boundaries. And should I now do it on your model file, creating a backup, of course. and then you get new things built. So this is the simple example model, and the right compartment side was just added the right box with the development client on all those build pipeline components, and including the deployment paths onto your production systems. So for those things, the data assets that are flowing is code and deployment unit. And they do have a very high integrity rating, because if you modify code or deployment unit, deployment artifacts, then you're code backdooring actually. Well, what about GitHub integration? So if you're into GitHub in terms of having build pipeline defined in your GitHub workflow style, there's an official GitHub Threagile action existing that you can just pull into your workflow, and an example project that you can also use as a template. And then here you see it marked run Threagile. So every time that model file, Threagile YAML, is pushed to the repo, then it's executing the Threagile model action onto that file and creating all those nice output artifacts that you can then process in one way or the other, or just simply store it in the and link it to the repo or something like that. Nice. Good. So what are the possible effects of things like that, this agile threat modeling thing? One would be to have some custom coded risk rules on enterprise scale that can analyze the model graph for some customer in some custom corporation policies, some individual policies that need to be applied across all the projects. So that definitely can be coded as a simple risk rule or a set of risk rules to apply these technical policies, like these components must never be stored close to these components, and there should be some component in between protecting that and isolating things and stuff like that. Also, you get some kind of uniform documentation of your system landscape, how it actually is, how the truth actually makes it to be. So that's created by the development teams in the IDE, and that's where the truth lies. So you see, actually, well, that's how the data is flowing. That's how my landscape looks. And you can instantly regenerate that. So if something changes, like a data classification on a new sprint, you get some health related data also. So it's now more on the strictly confidential side, you get new risks according to that. Or when you lift a component into the cloud, like a service now running in the cloud instead of on-prem, then you might get a new risk out of that as well. Or some more positive effects might be as well coming from that, depending on how you do it. And you can do this instant risk generation also corporate-wide. So on the whole landscape, for example, when one of your policies change due to some regulated domain you're in, and you have some kind of due date until which new whatever kind of thing needs to be applied. And if it's reflecting on a technical level in your models, then you can create or update a custom policy risk rule for that, and then just run it on your Threagile on all those models in your corporation, and you see which of those projects might possibly have some work to do to mitigate some new identified risks until this due date, for example. That's for me very important, being the DevSecOps guy also. So it's on the CI/CD pipeline kind of thing. So to also have some kind of automation check happening, like just fetching the generated JSON and checking that in a build pipeline. So as long as the model file is being updated and maintained properly, then in your CI/CD pipeline, we've seen that already with GitHub, you can get some nice automated generation of and detection of possibly unmitigated risks. So that can lead to trend graphs and warnings when a rollout, if you're doing it in an automated fashion, possibly contains some new unchecked risks that have not yet been checked by a human and have a high risk rating. So at the end, it's eventually making threat modeling as part of DevSecOps. Also, security is less bottleneck. That's for the security team, some kind of breathing space. So to have less pressure on vetting threat models from the technical side, so you can delegate as much as possible that can be automated to those risk rules in terms of threat model vetting. And then you can focus on the more business or more interesting high-level risks that no tool can ever identify. What are possible upcoming features? More documentations, of course. There's something, but still can be improved, of course, as always. More samples, more screencasts, videos, web-based model editor. If you take a close look into the code, you would see that the REST API is more than what's offered on the Swagger UI documentation. So there's the foundation for a web-based model editor. It's just that the UI stuff needs to be done. And so that you can add a data asset, add a component, add a trust border, trust boundary, and stuff like that to a model that's kept on the server side, if you want to do that. And model, very important feature, model linking. Model includes to have some kind of connections between submodels, that you can split your big models into a few smaller ones by those teams possibly, and reference them either by inclusion or by reference. And to have some layered graphs being generated where the surrounding models are either some black boxes with the connections going in, or a detailed view where the surrounding things are also more visible in a detailed level. More ideas are existing, like using the model macro approach to have something like a cloud crawler that you can use the read-only API then of the cloud, what is in your cloud, and then it can ask the modeling user what of these identified components and connections would you like to pull in that model file. Be nice. Same with CloudFormation or Helm or Terraform things, to seed a model file from this input, so to have your infrastructure also seeded via these things, and then a model macro can ask the user what kind of components would you like to automatically include in your initial model setup. Why not? I've seen a ticket online from GitLab. That's pretty awesome. I've seen it from the ticket. They are discussing to include that in their SCM workflow in GitLab CI as well. That's nice. It's already done for GitHub if you check that action. Some plugins would be nice for build pipelines, or some other integration with some architecture, enterprise management things could also be on the track. And well, why not include links to bug trackers, so that, or even defect dojo, why not? So that the developers can get the questions, or architects can get the questions they need to check for those risks, whether they have been mitigated or not, as tickets, so they can be bidirectionally linked. That would be a great idea, I think. So that's definitely also on the list of things that can be extended. And more. So if you have any feature requests or ideas, feel free to provide them on the GitHub repo so we can discuss on what should be implemented first. Definitely very nice. And well, as said, it's released as open source, MIT license, website Threagile.io. It's also having a playground, run Threagile.io. That's just a Docker container run in the server mode. So if you do not want to download it directly, you can still play with some sample things there. And there's a chat also in Gitter, and the source is on GitHub. And also a container on Docker Hub. So feel free to give it a try. And I'm really looking forward to any discussions and questions here. So that's it from my side. Thank you very much. Hope you enjoyed it. And yeah, any kind of questions, feel free to ask. Or also later, definitely on the chat. That's also something you can do. Okay, also on the chat here on the community, Threagile chat in GitHub. Good. Nice. Yeah, so then from my side, I would say thank you very much. Thanks for attending, and hope you enjoyed the talk. Also, hope you enjoyed the other excellent talks in the summit, and we'll do as well on the next upcoming ones. So from my side, again, thank you very much, and have a nice evening.
Hey, Christian. Hello. Hey, cool. So, all good?
Excellent.
Brilliant. No, this is pretty spectacular, right? I definitely want to really follow up. Let's already think about the stuff we can do in January, right? There's a bunch of sessions. I think we can follow it up. Yeah. But I definitely want to, get my team to give a test drive to this, right? This is pretty awesome.
Cool. Yeah. Looking forward to that.